Without using a calculator, solve the equation of root 3 tan theta plus 1 equals 0 for theta, where theta is greater than 0 but less than 360 degrees. To solve this problem, we want to use our 4 steps below, where step 1 is to solve for our trig equation. So in our question, we're given the equation of root 3 tan theta plus 1 equals 0. But we want to isolate for tan theta. So first we subtract 1 from both sides, and we have the root 3 of tan theta equals negative 1. Now dividing both sides by root 3, we're left with tan theta equals negative 1 over root 3. So now that we've solved for tan theta, let's label the quadrants that it's in. We know that our ratio for tan theta is negative, which means we must use the quadrants where tan is negative. We know in quadrant 2 and in quadrant 4, only sine and cos are positive, which means that tan is going to be negative in both of these quadrants. Now we know our reference angle is the acute angle between our terminal arm and the x-axis. So our next step is to find our special triangle to find the value of this reference angle. To solve this, we need to use tan theta equals negative 1 over root 3. But we also know that tan theta is opposite over adjacent, where our opposite has a length of 1 and our adjacent has a length of root 3. So looking at our graph, let's first make a triangle out of our terminal arms. We draw a vertical line to the x-axis, and then we can label our side lengths. We know directly opposite from our reference angle, we have a length of 1. But as we can see in our fourth quadrant, this length of 1 is in the negative region of our y-axis. So we make it have a length of negative 1. And we know the adjacent side length to this reference angle has a value of root 3. But as we can see in quadrant 2, this side length is in the negative region of our x-axis, so it has a value of negative 3. Now we have two legs with a side length of 1 root 3, which means our hypotenuse must have a value of 2. So we found that our special triangle is a 1, 2, root 3 triangle, where 2 is our hypotenuse and 1 and root 3 are our legs. Now of this triangle, we know that our angles are 30, 60, 90. 30 degrees is directly opposite from the length of 1, and 60 degrees is directly opposite from the length of root 3. Now looking at our graph, we can see that our reference angle is directly opposite from the side length of 1, which means our reference angle must have a value of 30 degrees. Now that we found the value of a reference angle, let's find our solutions. To find our solutions, we want to find the standard position angle of terminal arm 1 and terminal arm 2. The standard position angle starts from 0 degrees and ends at terminal arm 1 for theta 1, and starts at 0 degrees and ends at terminal arm 2 for theta 2. Now to solve for theta 1, we need to find the difference between 180 degrees on the x-axis and our reference angle of 30 degrees, where 180 minus 30 gives us a value of 150 degrees. But as we can see, our standard position angle for theta 2 passes 180, passes 270, but is just short of 360 degrees. So to find theta 2, we take 360 degrees from our x-axis and subtract it from a reference angle of 30 degrees. Now we have theta 2 equals 330 degrees. So our final answer is theta 1 equals 150 degrees and theta 2 equals 330 degrees.